This is a guide to the Unit 8 review packet. This video will be done in 3 parts, with each part corresponding to 2 pages of the review packet. Alright, starting with topic 21, interior and exterior angles and polygons. Question number 1, fill in the following chart. The formula for the sum of the interior angles of any polygon, regular or otherwise, is always 180 n minus 2, where n is the number of sides. So if we wanted to find the total for a decagon, the prefix deca means 10, so our value of n would be 10. So 180, 10 minus 2 will give us a total of 1,440 degrees for all of the interior angles. Moving on, hexagon, the prefix hex means 6, so we would have 180 times 6 minus 2, giving us a total of 720 degrees. Finally, the septagon, alternatively this may also be referred to as a heptagon. The prefix means 7, so this would be 180 times 7 minus 2, or 900 degrees. If we wanted to figure out how big one interior angle of a regular polygon would be, we would just need to take the total that we found earlier and divide that by the number of sides, which gives us 180 n minus 2 for the total, divided by the number of sides n, to figure out how big one of those angles is. For our decagon, we already know that the total is 1,440, so if we divide that 1,440 by the number of sides, 10, that tells us that each angle has to be 144 degrees. For our hexagon, we have a total of 720, divided among the 6 angles, 120 per angle. And finally, for our septagon, we have 900 degrees total, divided among 7 angles for a total of 128.57 degrees. For the exterior angles of a regular polygon, or any polygon really, the total is always 360 degrees. To figure out how big one exterior angle is, there's one exterior angle for each side. So if we just take our 360 total, divide it by the number of sides, that'll tell us how big each exterior angle is. For our decagon, total of 360, divided among 10 exterior angles, gives us 36 degrees per angle. Hexagon, 6 sides, it's 360 total, 6 exterior angles, 60 degrees for each angle. And finally, for our septagon, 360 total, divided by 7 exterior angles, 51.43 degrees. Number 2. Here we have to solve for the measure of this interior angle in this polygon. Now if this were a triangle, we would just add up all the interiors and set it equal to 180. However, the total interior angles for this shape is not going to be the same. So the first thing we need to do is figure out what all of these angles add up to. So this shape would be a 1, 2, 3, 4, 5, 6 hexagon. So the total for the interior angles would be 180 times 6 minus 2. And that gives us a total of 720. Since all of these angles have to add up to 720, that means I can write the equation 120 plus 135 plus another 135 plus these 2 angles here. This is marked as a right angle, which means this thing has a measure of 90. Of course, this one will be the same. So plus 90 plus 90 plus x equals our total of 720. If I combine all my constants, the 120, the 135, and so on, that's going to give me 570, and then I have my lone x. So x plus 570 equals 720. To get x by itself, subtract that 570 off on both sides, and that gives me x equals 150. Number 3, solve for x in the following regular polygon. In a regular polygon, all of the angles have to be the same, so I just need to figure out the total for the interior angles and then divide it by the number there are. So this thing has 1, 2, 3, 4, 5, 6, 7, 8 sides. So the total of the interiors would be 180 times 8 minus 2. And then I might as well do it at the same time to figure out the total for one, or the sum of, the value of one angle, just divided by the number of sides there are. In this case, there's 8 sides. So on the top, 180 times 8 minus 2 would be 1080 divided by 8, 135 for one angle. Number 4. Find the value for x, y, and z given the following regular polygons. I'm going to start by finding the values of x and z because I'm going to need those to figure out the value of y later. For z, z is in a quadrilateral. It's a regular quadrilateral, so I'm just going to use my same formula that I have been, total of the angles, 180. Here n is 4 because it's got 4 sides, divided by the number, and that's going to give us 90 degrees. Which should make sense because a regular quadrilateral is a square, and squares add up to 90. And my value of z is 90. Next, I need to find the value of x. So, 1, 2, 3, 4, 5, 6. This is a hexagon. 180, 6 minus 2, divide by 6. That is 120. Y is an exterior angle. Now, because the hexagon and because the square are regular, that means that all of the angles have to be the same. So if this angle was 90, it means this one has to be 90 as well. And if this is 120, it means this has to be 120 as well. All three of these angles, if you were to combine them, make 360 degrees, because it's a full circle all the way around. I can set that up as an equation. 120 plus 90 plus the value of y has to equal 360. Combine my like terms. 120 plus 90 would be 210. And then subtract that 210 off on both sides. And get a value of 150 for y. Number 5. If one exterior angle of a regular polygon measures 20 degrees, what is the measure of one interior angle? A single interior angle and exterior angle always make a linear pair, which means that they have to add to 180 degrees. So that means if I combine my exterior angle of 20 with whatever my interior angle is, they have to add to be 180. That gives me the equation 180 equals x, whatever that interior angle was, plus 20, the value of the exterior. Subtract my 20 on both sides and get 160. Part 2. How many sides does this polygon have? For an exterior angle, we know that the value of one exterior angle can be found by taking the total, 360, and dividing it by the number of sides, n. In this particular problem, we already know what the answer was when we did 360 divided by n. One exterior angle was 20 degrees. Another way of saying it is, when we did 360 divided by n, our answer is 20. To solve this, the first thing I want to do is get n out of the denominator, so I'm going to multiply by n on both sides to cancel this out. Next, I need to get n by itself. In order to do that, I'm going to have to divide both sides by 20 to cancel that out. And then 360 divided by 20 would be 18. So this figure would have 18 sides. For number 6, we'll start off by using the property of parallelograms that opposite angles are congruent, and this means that angle Q has to be equal to angle S, giving this a total of 110. Now there's more than one way to approach the rest of this problem, but for me, since I already have two angles of this triangle, I can use the fact that triangles add up to 180 to figure out that missing angle. So that's going to be 30 plus 110 equals 180 plus that missing angle. Combine my like terms. That's going to be x plus 140 equals 180. Subtract it off, and that's going to give me 40 for that other angle in the triangle. Because this angle is 40, and these two lines are parallel, it means this angle, QPR, and this one have to be congruent by alternate interior angles. So if this is 40, this one has to be 40 as well. And the same thing is going to apply to the 30. Because this angle is 30, this one also has to be 30. So moving down, we have the measure of angle QRP. QRP is this 30-degree angle. Measure of angle QPR. QPR would be the 40-degree angle here. Measure of angle S, 110. And finally, measure of angle PRS. PRS, 40. Number 7. Find the value of x and y given the following diagram and the fact that AE equals 3x, EC equals 2x plus 9, DE equals 5y, and EB is 20. I'm going to start by labeling this diagram the best I can. So AE is 3x, EC 2x plus 9, DE 5y, and EB 20. One property of a parallelogram is that diagonals bisect each other, which means that each half of the diagonal has to be the same. For this one, that gives me the equation 3x equals 2x plus 9. To get x by itself, subtract that 2x on both sides and get 9. Now I need to do the same thing with the other diagonal to find y. This means that 5y has to be equal to 20. Divide by 5 and get 4. Number 8. Use the following picture to answer the following two questions. If QR is 3x plus 5 and PS is 4x minus 25, find QR and PS. Opposite parts of a parallelogram are always congruent, so 3x plus 5 has to equal 4x minus 25. To get the x's by themselves, first thing I'm going to do is subtract this 3x from both sides. And then add that 25 to the other side. Now I have x, but I'm going to go back and double check. The question did not ask me to find x. It said find QR and PS. So I need to take my value of x and plug it in order to find these two. Because they're going to be congruent, I really only need to do one. So I'm just going to plug it into QR. So that'd be 3. And then where x is, we will replace that with its value of 30. 3 times 30 would be 90. 90 plus 5 is 95. If you wanted to check your answer, you could take your value of 30 for x, plug it into PS, and see if you got the same value. If you got 95 for both QR and PS, then you know your value of x had to be correct. B. If the measure of angle P equals 2x plus 3 and the measure of angle Q equals 7x minus 12, find the measure of R and S. In my parallelogram, R and S are not the ones that I'm given. However, because Q and S are congruent, because opposite parts are congruent, that means that S has to be 7x minus 12. And P and R are congruent, which means that R has to be 2x plus 3. Consecutive angles in a parallelogram are supplementary, so we know that these two things together have to equal 180 degrees. So I'm going to set up my equation as 2x plus 3 plus 7x minus 12 equals 180. I can combine my like terms. I have 2x and 7x, which gives me 9x. 3 minus 12 would be negative 9. And on the other side, still 180. To get x by itself, I'll add that 9 to the other side. And then divide both sides by 9. That gives me my value for x. However, this problem isn't asking me for the value of x. It's asking me to find the measure of angles r and s. Now, last time, I was able to get away with the fact that the two opposite sides were equal. That won't be the case this time. I'm going to have to do both of these separately. So first, I'm going to find the measure of angle r. We know that it's 2x plus 3, so this would be 2 times 21 plus 3. All right, 42 plus 3 would be 45. Because these two are supplementary and they have to add to 180 degrees, to find the measure of angle S, I can just take 180 and subtract off that 45. So measure of angle S, 180 minus 45, or 135. Number 9. Given ABCD is a rectangle, if the measure of angle 1 is 50 degrees, find the measure of the missing angles. All right, in my diagram, this is the measure. Sorry, this is angle 1, 50. Because it's a rectangle, I know that every single one of the interior angles all have to be 90 degrees. So if this side is 50, then the other side must be 40. From here, I can use the fact that the rectangle is also a parallelogram, which means these two sides are parallel and these two sides are parallel, with alternate interior angles, and just take this 50 and 40 and put it in every single other interior angle. So 1 and 3 would be alternate interiors, which makes this 50, which makes this part 40. Down here, same thing. 50, 40, 50, and 40. To figure out the measures of the angles in the middle, here I have a triangle. In this triangle, these two angles are both 40 degrees. We know the triangle has to add up to 180. So 180 equals x plus 40 plus 40. Combine these. Subtract that 80 off on both sides and get 100 for x. So that gives me a measure of angle 8. Finally, the last angle, 7. In order to figure out the measure of angle 7, we know that 8 and 7 make a linear pair, which means they have to add up to 180. So, if this is 100, the other side has to be 80. And now I can go down here and fill in all my values. Measure of angle 2 was 40. Measure of angle 3, 50. Measure of angle 4, 40. 6, also 40. 7 was 80. And measure of angle 8, 100. Number 10. In rectangle PQRS with diagonals PR and SQ, if PR equals 4x minus 10 and SQ equals 7x minus 40, find x, PR, and SQ. So here's my rectangle, P, Q, R, S, and it's telling me that the diagonal PR is 4x minus 10, and SQ is 7x minus 40. One of the properties of a rectangle is the diagonals are congruent. That means that PR has to equal SQ. 4x minus 10 equals 7x minus 40. Need to get all the x's on the same side, so I'm going to subtract this 4x on both sides, which will give me 3x over here. Next, I need to move this 40, so I'm going to add 40 to both sides. And finally divide by 3, which will give me 10 for x. Now I need to go and find the length of PR. So I'm going to take this value of 10 and plug it into my value for PR. That would be 4 times 10 minus 10. 40 minus 10 would be 30. Since the diagonals of a rectangle are congruent, if PR is 30, it means SQ also has to be 30.